Okay, so huh. So one of the problem of using multiple protocols is that it causes suboptimal routes. So we want to understand how that happens. So RIP will advertise the network 2.2.2.2. It will advertise it. RTD will advertise it in RIP. Then RTC will import that particular route into ISIS. Then that is how RTA will learn about that particular route. And at that point, it will have a preference of 15. So you see, RIP, the preference for RIP is 100. You know that routers will look at the routing protocol preference to know whether to import the route in the routing table. So the higher, the lower the preference value, the better. So the default preference value for RIP is 100. For ISIS, it's actually 15. Okay. So RTA will also advertise the same route to RTB using ISIS. So that means that RTB, as you can see here, RTB will learn about this network from two sources, from ISIS and from RIP. So now, because RIP has a better because ISIS has a better preference than RIP, then RTB is going to install this route that has been learned by ISIS to this destination in the routing table. And if it installs it in the routing table, then the next hop for going to that network is going to be 12.12.12.1. So it's going to forward that packet to RTA, then RTA to RTC, then RTC to RTD, then finally there. So as you can see, that is a suboptimal route because RTB should generally forward that particular packet to RTD. That's the optimal route. And now the problem is with the preference. It has learned the same route from different protocols. And the one that has the best preference is actually offering the suboptimal route. So how can we rectify? How can we rectify that problem? So if you look at the routing table for RTB, you can see that what has been installed in the routing table to this destination network is actually the route that has been learned through ISIS. The preference is 15, and the cost, the next hop, I'm sorry, the next hop is 12.12.12.1 via serial interface 0. So again, as I said, when it comes to what is installed in the routing table, it is the preference first. If the preferences are the same, they look at the cost. So when we were looking at introduction to routing, these are some of the things that we looked at. Okay, so one of the solutions to this is that we can filter routes. We can filter specific routes so that they cannot be learned by RTB. So in RTB, we create an ACL and we specify a rule that will deny anything with that particular network address. Then we go into ISIS and we say filter policy. Then we specify the ACL number and we don't want to learn it. So import is for learning. exporting is for advertising. So now, if we do display IP routing table on RTB, we are going to see that now the route that has been learned through RIP to that destination is going to be installed in the routing table. It has a preference of 100, but most importantly, the next hop for this route is the optimal one with so really from now henceforth, due to that configuration, packets from RTD to packets from RTB that are destined to this network are going to be forwarded to RTD. So I hope that is clear. So that's one of the solutions that you can implement there. The other one is we can also adjust the protocol priorities by changing the preference value. So other than using the filter, we can also change the preference value. So here we're simply saying ISIS1, then we're changing the preference value for ISIS1 routes. The default preference for all routes that have been learned through ISIS, we're changing it from 15 to 150. So it's gonna have a bigger value than that one for IRIP, which is 100. And once we configure that in RTB, if we do display routing table, then the route to the network 2.0.0 is going to be learned through RIP with a preference of 100, and the next hop is this particular interface here. So those are the two ways in which we can solve that problem of suboptimal path. The other problem that can be caused with using multiple protocols in such like a scenario is loops. So we can easily create loops. So let's look our way as number one. So RTA here, RTA is connected to a network 2.2.2.2/32. So it wants to import this route into OSPF. So import direct. So it's going to import it. When it imports that particular route, you see the preference for external routes is 150. The cost is going to be 2. So it's an external route, ASC, AS external, autonomous system external. So we advertise it. This guy will advertise it to RTB. RTB will also advertise it to RTC. So that is number one, number two, number three. And RTB will also advertise it to RTE. So because all these routers here are communicating using OSPF. So that is number one, number two, number three, number three. Okay, so let's look at number 4. So let me clear. So at number 4 here, RTE is going to advertise that route into OSPF, into ISIS. So that's what we're doing here, importing OSPF into ISIS. So once we do that, we're going to advertise that route number 5 to RTD. RTD is going to advertise it to RTC. In RTC, we have also configured an import so that we can import routes from ISIS to OSPF, just like we've done here in RTE. In RTE, we've configured, we import routes from OSPF to ISIS. So here, the same route that is coming from OSPF is going to be injected back, into OSPF with a cost of 1. So as you can see, a loop has occurred. A loop has occurred. If you follow these arrows, you can see that we already have a loop. So that is the other problem with using multiple protocols in such like a scenario. So what will be the solution? So we import the direct route. So this is exactly what I was demonstrating. So we have a loop. So the solution to this, so we can still go ahead and import this particular route to OSPF1. But now, then on RTE here, we import routes from OSPF into ISIS1. So we've done that. We've imported routes from this guy to this guy. But now here, we need to exclude such certain networks. So how to do that? We create an ACL. Then we do rule 0, deny that source. Rule 1, permit any other. So we are denying anything that is coming from this network. So we go to OSPF1 in RTC. Then we say, when you're importing from ISIS, apply route policy RP1. So what does route policy RP1 say? So route policy RP1 permit node 10. So we are simply saying if match ACL 2001. So ACL 2001 is simply denying this route. So this route can no longer be advertised from ISIS back to OSPF because already we have advertised it. Because when we do this import, we will advertise it here. RTB will advertise it to RTC through OSPF, this one through OSPF. Because we've done an import here, we are going to advertise it to RTD. RTD is going to advertise it to RTC. And now RTC cannot import this route back to OSPF because of configuring this route policy. So these cannot, so that way we prevent the loop. We prevent the loop from forming. Okay. So the other solution to preventing the loop is adjusting the protocol priorities. So where are we doing that? So what we're doing here is just the same thing. We import the direct route into OSPF, then we import OSPF into ISIS in RTE. So in RTC, we can change the default preference for ISIS to 160. Then if we do OSPF1 import route ISIS1, we can display the routing table. We can display the routing table and see that only the route that was learned from OSE, from AS external, which has a preference of 150, will be installed in the routing table. So we've changed the preference for ISIS1 to be higher than the preference for AS external, ASE. So once we do that, then the routes that has been advertised by ISIS1 is not going to be installed in the routing table, because in the routing table only the best route is installed. based on the preference, and then the cost, and so on and so forth. So I hope that is clear. Okay, so that is the end of this chapter. That is the end of this chapter. Thank you for your patience. Again, this one is quite a long chapter. I don't want to ask you to answer these questions now, but I want you to take the next 5 minutes and try and answer them. If you're unable to, you can check the explanations that we have below. Anyone with a question? Okay, asante.